And they start popping in. Hello, everybody, and welcome to our first live stream of 2023. This is our plot compression Q&A call. We would like to keep this relatively on that topic. This is not a general AMA. So if you all have any questions or anything about the plot compression stuff we've announced recently and things related to that, we're happy to go into it. Please don't be offended if we don't bring up questions that you've asked about other related stuff, unless it's somehow relevant. We're going to do our first major AMA of the year, probably here in another week or two. And so you can kind of save all that stuff for then. As always, if you have questions, please use the Q&A box in Zoom to ask the question. Don't put the question in chat. We won't necessarily see it. So put your questions in the Q&A box. And we're going to also pull some questions that we've got over the last couple of days pre-staged on Reddit as well. With that, let's do a quick little run around. Everyone kind of say hi and who they are for those of you who haven't been here before or haven't been to Ways in a while. We have a couple of new faces on this call, one specifically new face. JM, you want to go first?
Yeah, hey guys, John Michael Hands. I'm our VP of Storage. I do lots of things plotting and farming. My background's in SSDs.
Harold?
Hey everybody, this is Harold Brennis. I'm an engineer here at Chia. I mainly focus on plotting, so I'm mostly working on Blade.
Bram, I don't think anyone knows who you and Gene are. You guys want to say
hi? I'm Bram. I did some initial design work in our plot format and plotting algorithms.
I'm Gene. I did some initial choice in which plot size we'd use.
Speaking of, we'll start with that. That's our first question actually that we got in. Do we have any estimated timeline or any thoughts or plans on when we would expect the K32 size to be end of life? Should we expect people will have to replot to a K33 in 2024?
We have no specific plans on when to do that, if ever.
Yeah, the one caveat is if the community were to decide that we don't want to do the plot filter hard fork, that might require us to move to K33, but we generally are, on the side of doing the plot filter hard fork and therefore not having to move out of K32 for a while.
That's kind of a trade-off that we have is we would like to improve our security parameters a bit because we think we were a little too aggressive with things. All the plans involve either a whole lot of people doing a whole lot of replotting or a hard fork. We would like to avoid both of these things. However, we don't want to skate too close to the edge. And we think that a simple hard fork to just change basically just a number is not going to upset people all that much. It doesn't favor anybody or anything. And it has, in some ways, some of the same kinds of effects as switching to, as turning off K32 and requiring K33 would, because it does make farming more intensive. And a good way to make your farming less intensive is to use K33s or K34s.
Okay. So I think since today we have a little more than just some Q&A stuff, we have some stuff I want to show as well. I think unless you guys feel differently, we'll probably hit a couple of the really big burning questions real quick. And then we'll kind of turn it over to JM and Harold, and I'll give you guys about 20, 30 minutes tops to kind of run through the stuff you want to demo and show. And then we'll go back to questions from there on out. Does that work for you guys?
Yeah, I'd like to add one thing to kind of Bram's answer before we move on, sure. Which is the reason that we're concerned in any way with the plot filter or the minimum K is a very kind of rare attack of basically like taking every single A100 GPU in existence on the planet and trying to 51% attack Chia over an hour. It's unlikely, but what we want to do is make sure that it remains extremely unlikely. And we think the best way to make it extremely unlikely as we get to the next series, I think it's H100, is that right, Harold?
Sorry, I missed that.
I was asking, I'm trying to remember what NVIDIA is next after the A100 is. But anyway, point being that these things are fast. And so for short range attacks where you try to double spend in like an hour and like maybe attack our new bridge, for example, that's the reason why we're concerned with this. It's not a very practical attack in any way, but this makes it stay outside of any sort of practical sense.
Yeah, and just a reminder on that, we, for those that aren't kind of following we had a blog post about GPU plotting, and actually the majority of the blog post was actually about network security. We're actually talking more about the GPU plotter today. But in the blog post, we actually go through Bram and myself's rationale for kind of how we thought through this, the different options we have to look at now what we're calling plot grinding, and protections from that we have on the network through constants. So yeah, if you haven't read the blog post and the chip, we do go through quite a bit of those trade-offs. But Bram mentioned it really came down to, do we make everybody replot, or do we do this thing with the hard fork with the filter that is actually will be pretty non-disruptive to most folks that are farming. So
okay. So there's a couple really common questions I've been asked in a couple different ways that are kind of high level. I'll hit a couple of those real quick, and then I'll let you two kind of start your little demo. So one of the biggest questions I think is simply, when can we expect to see some of this? Like, is it going to be available in like some people think we're going to release it today? We're not. Spoiler alert, we're not. Is it like matter of weeks? Is it months? And then the second question that I think kind of ties into the when, so I'll go ahead and preload that as well, is the question of farming. Do you have to use a GPU to farm some of these things? Will we even be able to, with the Chia software, to use a GPU to farm them? And then what's going to happen to the Raspberry Pi folks who use Pis as harvesters or lightweight farmers as well?
God, dude, that was like 5 questions.
Well, they all kind of go together though.
Yeah,
So
I'll answer the first one, which is the when. So the plotters are close. So we'll show you some demos of the plotters today, and we'll be releasing a technical alpha for the BladeBit CUDA plotter, and Harold and I are going to give you a demo of that today. Most likely in the next couple of weeks. It could be within a month, but the idea is that we'll be able to create the old plots as well as the new compressed plots. There's some stuff that we have to go through and finish the final validation testing of the sizes we've chosen, make sure that they're all happy with the farming software we're writing. And but most of the team felt that it was pretty silly to release the compressed plotters without the ability to actually farm them. So Harold is also working on developing that. And so the answer is when it's done, when it's done, we'll release it. I think we'll probably have a plotter in the beta program slightly sooner than the farmer, just because you'll be able to make the old plots as well as the new plots. So there'll be some benefit there of having it a little bit earlier, even in alpha state. And when we release it, it'll be Windows, Linux. We'll talk about there's a lot of questions about GPU properties, operating systems compatibility and stuff. We'll get into that here in a little bit, but
yeah, and to that last part you said, I want to kind of set the understanding with folks who probably I'm going to see this question come up a lot. I'm already seeing it coming up in different places repeatedly. And the question is like, what's the optimum setup? And folks really need to understand, we got to drive home the message. There isn't a one size fits all solution when it comes to this technology. There are many factors that play into it. Some of the most important ones is, what do you pay for power? How many plots do you have? What kind of hardware are you currently farming with? What kind of hardware do you have available? And all that will factor into kind of an optimal setup for you. And so the real answer is, you have to look at all the data we provide, and you have to do some trial and error, and you have to decide what in your scenario works best. There isn't a look at this spreadsheet and pick the things at the top of the list and use those, and you're in the best scenario. That isn't the case here. So
Yeah.
Well, but I want to add though, if you compress to like 4 or 5, you're really unlikely to have a piece of hardware that cannot farm 4 or 5 on CPUs.
Correct.
And so, there's some PTSD out there from former bursters who are like, oh my God, it's breaking like burst. No, it's not. What it's doing is making it so it's easier for really large farmers to use a GPU to keep the farming CPU load down, and everybody to be able to plot with GPUs if they want to. But you don't have to. You can plot compressed plots without the GPU. It just takes you a little longer.
Yeah, you can. There's 2 things going on here, somewhat separately. We have accelerated plotting. Now, generally speaking, faster plotting is a good thing. Uses less resources, happens quicker. It's just good stuff. That's true until it gets so fast that it makes plot grinding practical. And we are nowhere near the range where plot grinding is clearly practical, but we want a really big safety margin around it being not practical, is why we're talking about taking countermeasures. That's kind of high level of why we're talking about these 2 seemingly somewhat unrelated things. As far as resources involved in in farming once you're done plotting. So you will be able to plot using non-GPU or GPU, either way. GPU is faster. If you're farming, if your compression level is set low, to not to the 0 like it is now, but to the lower end of the range of what's plot grinding, then nothing's going to notice this. Even a Raspberry Pi won't notice it. If you get higher, then the farming machine will notice it. We are going to, another thing that we're not announcing dates on yet, we are going to have an enhanced harvester protocol where the actual the actual bit grinding to finish recovering the thing when you find it can be moved off the harvester onto the farmer, which will be a good solution for a lot of people. But that's a separate thing for us to release.
All right. The last topic I want to talk about before we do demos, and I know the demos is going to heavily also give us opportunity to kind of dive into this a bit more, but I want to kind of just get this out of the way. Does someone want to do in less than 250 words? Why is Chia not going to proof of work, and why is it wrong to think so? And why is this not even a proof of space and time / proof of work hybrid, as some are calling it?
Yeah, so you have time space trade-offs, right? That the more computation you use, the less space you need. In something like Burst, which doesn't have the multiple tables, these get pretty gnarly, that you could just kind of keep throwing more and more CPU and it keeps getting more and more benefit out of it. With the way we design things with the multiple tables in Chia, when you start doing time-space trade-offs, the benefit that you get for them goes down exponentially as the amount of computation you throw at it goes up. So at some point you get kind of a reasonable medium where there's some amount of computation that basically everybody can do, where you're talking about like 1%, 0.1%. You're getting down to very small amounts of extra compression that you're getting beyond that as you throw more computation at it. And that this doesn't accelerate. Like the bit dropping approach to things is a bit better than the approach that we knew of before. So a certain proprietary plotter came out and we were wondering how it might work. We still aren't 100% certain about how it works. But once that came out, we kind of independently came up with what we think is what it was doing, which is a different approach to time-space trade-offs than the one that we were aware of before, which is Hellman time-space, Hellman attacks, Hellman time-space trade-offs. The bit dropping approach, the comparisons are complicated. It gets you a few more percent compression than Hellman's time-space trade-offs do in practice. There's a lot of specifics of K32 and stuff. It has the benefit that it actually speeds up plotting instead of slowing it down a lot, which Hellman time-space trade-offs do. So it's just kind of a clearly better approach. As it happens, we didn't come up with it. We came up with a lot of things on plotting. It's okay for us to not come up with every single idea everyone could ever come up with first. But yeah, this seems to be generally a good approach to doing things. But we don't think there are more algorithmic improvements like this waiting in the wings. You get this pretty clear, here are the trade-offs that you have, and here's the benefits that you get. At a high level, the resistance to the thing, the resistance to these attacks, how quickly the exponential it goes down is, it's kind of based off the number of tables that there are. And so we have 7 tables. Adding more tables would make it more resistant to time-space trade-offs, but not a lot more resistant to time-space trade-offs as you increase the number of tables. And would have the downside that it increases the costs of plotting pretty substantially as you do that. So I'd gamed out a bunch of this stuff, assuming Hellman time-space trade-offs, which aren't that different, when the plots were being designed in the first place. So it's kind of playing out roughly as expected. And
I'd just say it in the shorter version, plotting got more efficient and therefore cheaper and easier. At worst, we got 10% more annual energy expenditure, which I doubt, but that means that we're still 720 times more efficient than proof of work.
Okay.
Yep.
Alrighty. Let's go ahead, Jan and Harold. You guys can show off your shininess if you want. You guys should be set up to do streaming. I'm not sure which one of you wants to share, but
Harold, who's going first?
Go for
All right. Well, I'm just gonna, so it's easy for me. All I have to do is mash a button. Harold actually did the hard work. So I'm sure a lot of folks are going to be, asking a lot of questions. In the blog post, obviously, we detailed quite a bit about the GPU plotter. So Harold's been developing BladeBit CUDA, which is using a lot of the BladeBit code, but obviously re-architected for CUDA. A lot of people are asking questions along the lines of like, how do you, what aspects of this GPU plotting actually affect performance? Well, in the blog post, I go quite into depth on CUDA performance, which is just the number of CUDA cores. That is a significant impact to performance, but you'll hit other bottlenecks. The other bottlenecks are PCI Express bandwidth and memory bandwidth. So between these three things, these are generally going to be the majority of the bottlenecks once you have the system resources. So the very first version of BladeBit CUDA that we're going to release in the alpha is going to require 256 gigabytes of DRAM, but it is done completely in memory. So there's no disk writes, no SSD wear, no wearing out drives. It is done completely in memory. And the way that it works is basically the buckets get created kind of similar to how we have the bucketized approach for the CPU plotter. The buckets are pinned. We have memory that is pinned in host memory that the GPU and the host can share. And there's a certain amount of memory. Harold and I had a long conversation last night about some arbitrary limitations in Windows that they set on this type of pin memory. But basically that the GPU and the CPU can access. Well, they can't just access the memory, but they have to actually access the memory across the PCI Express bus. So in practice, this plotting, what you'll see is a lot of PCI Express bandwidth between the host CPU and the GPU, because it's passing these buckets and DRAM and during the plotting phases across. And then the GPU is actually cranking. Obviously, you can see here my NVIDIA SMI. This is a 3090. It's taking about 200 watts or so doing this plotting. But you can see here, where are we? Phase one. Completed phase one in 37 seconds. So, we actually still have some optimizations to go. Harold thinks we can get it faster. I don't know. But I think after we talk a little bit more about where we are today, we'll talk about, there's a bunch of questions about like, what are we doing next for the I know, so this first version is like the guns blazing, super fast mode. And Harold will show you his system has got, I think, a 3070 on it. But you can see we're doing a plot in 91 seconds, 1.52 minutes. So we could spend another month shaving that down another 10 seconds or so. But I think we're going to probably start moving on to, of course, the other things that the folks want, which is farmer support to be able to farm compressed plots, actually having different GPU methods to be able to offload some of this DRAM requirement to temporary SSDs. You can do this on desktops and other systems. So anyway, we'll walk through a bunch of the roadmap here stuff in a little bit, but that's it. Basically, this is what it looks like. You allocate 256 gigabytes of host memory, and almost nothing is happening on the CPU besides some background memory writes every once in a while in the final plot, right? But so yeah, that's kind of where we're at. So that was a high-end card. I know Harold can kind of demo like we're obviously testing not just like super high-end, super expensive cards. That's just the one I happen to have in this workstation right now. But we're testing entry-level cards on the 3 series, which go for about $200, $250 for a 3060 Ti. I'm sure there's going to be a lot of folks that are testing some older cards, and we'll kind of go through that. But Harold.
Yeah, I'll share mine and I'll explain a little bit more about what's going on. Jim, yours is a 3080, isn't it? Not a 3090?
3090, yeah.
3090 or 80?
90.
Okay. So you're using it. So yeah, I'm using a 3070 Ti in this one. It'll show at the beginning here. We just run a plot. At the beginning, it's deleting the previous plot that I ran and rebuilding just in case. So here shows that it's a 3070 Ti. This part at the beginning is taking a little bit longer now, but it's just yeah, we're still in development. It should take a little bit less later, and we might change it so that it doesn't do it up front. It's like a warm start on the current Blade run or in this one also. So a few things about what JM said regarding the optimizations and that kind of thing. We're pretty close to basically being completely limited by PCI throughput right now. There's a few more things that I still have to do. Even though at the state it currently it finds itself, it's good enough, we think, because most people will be limited anyway by transferring it to their target devices, the target drives. So this one should finish a little bit slower than JM's, but there's a little bit room for improvement in this one, the compute, or since this one's still a little bit slower than the transfers are taking. But once in the 3080, I believe we tested, I'm not sure if it was 38 or 3090 JM, and that one, the compute is already a little bit, it finishes faster than what the transfers are taking between device and host. So I guess at that point, there's no point in getting a faster card because you're going to be slowed down by the PCIe 4 bandwidth anyway.
Yeah, so this is an important question for folks. I know a lot of people are like, should I rush out and buy a 3090? I think you'll see Harold's 3070 Ti here is actually going to be extremely similar times to mine, maybe 5 to 10 seconds difference. Suggesting, yeah, if we're limited by PCI Express Gen 4 bandwidth, then yeah, there's no reason to go out and buy the most expensive card. Like we think these entry-level 3 series are going to be probably the sweet spot. The other really exciting part is that once you have 56 gigs of DRAM, you know, the older DDR4 ECC for you can buy for a Xeon V3 or V4 or Skylake or Cascade Lake. Even though those systems are Gen 3, we're still seeing about 3-minute plot times at PCIe Gen 3 with these lower end cards. And you can get 256 gigs of DRAM for $300 on eBay, maybe actually even a little bit cheaper if you want to buy the 2100 DIMMs. So, you know, combination, like the cheapest possible setup is going to be buy used workstation for $100, buy used CPU for $25, you know, buy 256 gigs of DRAM, $300, and then throw a $300 GPU in there. Now you're doing 3-minute plots. So this system that does 3-minute plots today costs $4,000, $5,000. You know, now you can do this entire thing for $600. So it's just mind blowing, like how much this is going to open up for folks that want to do plotting. So,
and to clarify this, we're doing compression level anything from 1 to 7 in this case, which drops 1 table. Support for dropping more than 1 is not in yet. So if we had that, should drop probably around 10 seconds. We'll see after the optimizations, the next optimization pass is done. Can share real quick how the profiler looks like. You guys have an idea what I'm speaking about?
Cool.
So, is that visible?
Yeah, you can see it.
So this is my 3070. Blue stuff is a compute. Pink or purple, whatever you want to call it, is downloads, meaning from the card to the system RAM, and these are greenish blue are uploads. So from host to device. As you can see, they're both smaller in my case than the compute. So right now, like I said, there's some gaps in there. That's simply because of the way I'm currently doing some stuff for testing, but we should be able to get them contiguous and hidden completely behind compute. So anything 3070 and below, you'll be limited by compute. It looks like so far we'll do another profiler pass on the 3080s and up. And so far it looked like you might be limited at that point by memory bandwidth or PCIe bandwidth. So we'll see after that. We'll let you guys know once we finish this next optimization pass and share it with you guys. I think that's all for me, unless there's any specific questions.
Alrighty. So yeah, so that's our kind of live demo of what we got. I think a lot of folks were kind of speculating in the last week or two that we actually hadn't finished building anything yet, and the answer is, oh no, we have. We said this in the blog post, but I think it kind of got lost in a few people. The farming stuff, like, we've gotten very far on, and in theory we could release in a beta now. Just as I've said in many other places, there's no sense in us releasing plotting software. There's no sense in us releasing plotting software to you guys that you can't farm, because it would just lead to a lot of people replotting and then being like, hey, when can I farm this? And it's like, well, we told you it's not ready. And it leads to confusion. So we want to release
clarification real quick. If you notice that we're both getting the same table counts, we're using the same plot ID just for testing, so we can actually get so if anybody's wondering, and we'll publish those plot IDs so you can test against those. So you know exactly the same times you're getting versus the ones we're showing here in your machine. So this is the same one I use usually in Blade, so it's completed code base, but just in case you wonder why we're getting the same table outputs each time.
I didn't even notice that myself. It went right over my head.
So
I'm sure there's definitely folks watching though who probably saw that. So thanks for clearing that up.
well,
so yeah, so we've got some awesome stuff that's well underway for you guys, which is why we wanted to show it today. And with that said, we have a lot of questions now that's kind of built up. So I'll kind of start going through those, and I'll start tossing some questions to you guys. JM, I'll send one your way first. With the BladeBit GPU plotter, is there going to be plans for supporting higher case sizes?
No, absolutely. No, the tricky part is, like, how do you support higher case sizes without, like, just doubling the memory requirements every time? Because that's easy, right? You can, if we say, oh, you want to do K33, but just double the memory, actually, most of the time that Harold's been spending this last week, we're just trying to get the memory footprint down to, a spot that makes sense for a lot of normal people. But which will really help, though, because this will go into the other versions of BladeBit eventually, well, as well, Harold, right? So
that's correct.
When you say other version of BladeBit, I'm kind of dovetail off that. When we say other version of BladeBit, is there a plan for us to release this to where there'll be two BladeBits? There's the BladeBit that does everything but compressed plotting, and then there's this one. And then is there a plan to eventually just have one BladeBit that you pick from whatever you want?
Yeah, I think right now there will be two binaries, one binary that does RAM plot and disk plot, and then one binary that does CUDA, because as you saw, that you have to do some of the CUDA stuff when you compile it for the developer kit, and that's not required for people that don't have the CUDA card. But yeah, there's no reason eventually we can't release binaries that can do all this stuff.
Long run, there's going to be very, very little reason for anyone to do a plot that doesn't have some level of bit dropping compression in it, because the minimal ones do make meaningful compression and come with essentially no CPU cost. It should probably mention, I think we haven't made this clear, we have other plot compression stuff that's been in the works for a while that's actually quite a bit more involved to implement than the bit dropping is. So we'll have another plot format probably in the future that incorporates those on top of bit dropping. That will probably get around another 1 or 2% compression, but have the benefit that it has no real CPU downside whatsoever, either on plotting or farming.
Okay. Let's see here. What else do we got? Here's one for you, Bram. This person, nice enough, said, they already know the answer, but they're asking for everyone else's benefit. So I appreciate that. This is a great question. Can we explain a bit better why the Raspberry Pi is still usable as a farmer after all this comes out, and why they haven't been relegated?
Earlier, but I maybe should not give too much information.
Yeah. So the reason why I'm re-asking is when we first touched on this, we had like 40 people in the call, and we now have like 150. Yeah. So I want to kind of make sure that this is really covered.
Yeah. So I apologize for throwing out too much information without context earlier, but the answer is, there's sort of two answers to this question. One of them is that if you use a low compression level, the Raspberry Pi can handle it just fine. And the returns as you increase the compression level go down pretty fast for the amount of CPU that you're having to use. The other answer is that in the future, not yet, we will have an enhanced harvester protocol where the bit discovery, the grinding on figuring out what the bits were, is not happening on the harvester, it's happening on the farmer. So if you have a farming machine, which is like a real machine and not a Raspberry Pi, that's connected to a lot of Raspberry Pis that are doing the harvesting, that the machine that's actually doing the farming is able to finish it up, and it's no extra load on the harvesters whatsoever.
And that goes through, somebody asked a question earlier, Jay, but I don't think we actually answered it about GPU farming. If you read the blog post carefully, today we're releasing levels, 1 through 7, which is basically, up to table 1, and that would, even level 7 gets a little, hairy on CPU. You'll definitely have to throw some threads at it. One thread might be a couple seconds. So it just depends on how many plots you're farming. Before we go to the next levels, a couple more levels up, we are going to implement a GPU farmer at some point, right? It's on the list of stuff that Harold and I have to do. As you guys mentioned, there's some people that would like to see K33, K34. We really want to get the requirements down so people don't have to buy a workstation, that some people can do this type of GPU plotting at a desktop. That's kind of next up on the list. There's quite a few things on the list. So we're talking about priority and how we juggle the sequencing of all that. But yeah, we're going to build it all. It's just going to take a while. So
yeah, we continue to do a lot of work on plotting and such. Unfortunately, like I personally am spending like no time on this because, we as a company don't get much direct benefit off of these improvements. It's like we get ongoing security for it by having things not be proprietary, by having everyone be on an even footing out there. Although our focus as a company is very much on like Chia Lisp and new features on that level that have real like end consumer things. So we continue to put resources on plotting, although I wish we could put more. It's just that we
Yeah, and there's an important point here. As long as you basically set up your Raspberry Pi decently, the worst case scenario is the absolute like crazy people who are trying to compress deeply have at most like a 5 or 6% advantage on you. It's not like it's material, and it's probably not even that much of an advantage. So the whole point here being that, this is a relatively mild set of changes to how the whole system works.
Mm-hmm. All right. So next up, there has been talk about, we touched on a bit earlier about the proposed chip out there currently for filter adjustments to what we're now talking about, plot grinding, to kind of prevent that. Bram, there's a question that was asked, are there any other things that we could do within that same hard fork that we do the plot reduction that could, be a part of that? And then also along with that, do we think that in doing that change, we would make any changes that allow us to continue making those adjustments via a new soft fork rather than continuing to have to hard fork it each time?
So kind of two answers to that. Number one, the format of it, of what we're doing, is designed to actually be a little bit overly aggressive on reducing the plot filter. The theory being that if we're too aggressive about reducing the plot filter, increasing it in the future is a soft fork. So we are thinking about that for the future. We really don't like doing hard forks. Arguably, I should have thought of this beforehand. I'm sorry, I sometimes miss things. But it does reduce the filter on a schedule over a period of years to the point where it's getting pretty darn aggressive towards the end of it. Yeah, so there's that. As far as other things that are kind of on a potential wish list for hard forks, it's kind of early at the Chia Lisp level to be monkeying around with much of anything. There's things that I would vaguely like to be different, but it's far, far too early to be saying, oh, it would be nice to do things this way. And most of the things that would be nice to do can either be done via the soft fork opcode or via the or by having an extension block at some point in the future if we're going really different. And also, it might be good to use those just to get in the habit of using those rather than saying, oh, we just hard fork things. That said, most of the chips that we have in for enhancements are actually soft, or work quite nicely as soft forks, that there's no an even temptation to do any hard fork for them. The one thing I would say is for the BLS opcodes, and also I think we included in there an opcode for calculating coin IDs. It's convenient if those aren't behind the guard. So we may do something where we kind of like soft fork those in behind the guard. And then if we're doing a hard fork anyway, maybe we could make those opcodes work outside the guard. Because the problem with doing that is that it's a hard fork, but if we're doing a hard fork anyway, maybe it's okay to make those convenient so you don't have to use the soft fork extension opcode for them.
Yeah, just to be clear, we're thinking about which ones of those we can sneak in, because it's just a nice way to clean up. If we're going to do it, might as well make this easier for everybody.
Yeah, I think that was the gist of the question was, are we going to use this as an opportunity to make things more elegant? And the answer basically is yes.
Yeah. So we're going to go ahead and get the soft fork, the hard fork quote done, unquote. Remember, it won't activate quickly. So that may rule out some of the things would be nice to get because they may not be ready.
On that, there's other questions that have been asked about doing the hard fork, and that is if the chip is not universally rejected by the community and we do decide to implement it, do we have like what timelines we're talking, like when do we plan to actually put it out there, when do we plan to actually activate it?
That's actually a really good place, Jay, to describe. We have a process for the chip where we'll have a chip video. Now that the chip is open, people can leave comments. There's some folks that have left comments. I see, John for Chia Links has released, put some really nice comments and thoughtful questions in there. We could probably spend a whole hour on just those questions. So we will do a separate chip call. But a lot of people are, if you read the blog post, you'll see that there was, we did spend quite a bit of time of describing this block grinding thing and the whole motivation behind this. So that should be, if you want more details on that, hopefully what you just saw, in the demo will provide some light on that.
Yeah, and that's actually a great place to remind folks. We do calls just like this one for chips when they're in the open discussion process. We generally don't have the biggest turnout. It's usually like 4 or 5 community members who are either involved in all the chip discussions, or 4 or 5 community members who just are very invested in that particular chip. Aside from that, we don't have the biggest community turnout for these chip discussions. We'd like to see more folks involved. We try to socialize as much as we can to get their attention. This one, I suspect, because of the nature of what it is, will get, I think, a lot more traction and more people will show up. But we do calls that are kind of like an open discussion panel Q&A specifically for these chips, and they're recorded and archived and they're posted to our YouTube site. So they do exist. People do have a chance to kind of chime in on those things, and there will be one for this one.
Yeah, but by their nature, hard forks are much more potentially problematic than soft forks. So you do need to leave a much longer lead time before they actually activate, because people not having upgraded causes a lot of problems by default. So you want a very long time period.
Right. Alrighty. So this question, I think, is a great opportunity, Bram, for you to talk a bit more about the farming process. Not too technically deep, but a little bit more than people may understand, because I think the question sort of doesn't quite fit with how things actually work, which is a great way to kind of cover this a bit more for those who don't understand. And the question is, will compressed plots take longer to return results, thus reducing your chances of a win versus an OG plot that already have the work done and will return results faster? First of all, because you don't lose if you have a valid result, you have a valid result, which you can go into, but then also how this works as well.
So the way the network protocol works as a whole, there's some quite involved things in there to make it so that you do not pay a penalty for having extra latency to the network. Now, this only works to a point. So if your latency is like 1 second versus 5 seconds, you're paying no penalty whatsoever. If your latency goes over 30 seconds, you're getting nothing. So that's it kind of acts a bit thresholdy in terms of how it works. As long as you're below that, you're kind of okay. Now, in principle, all the bit grinding is it can be completely parallelized. In practice, you probably just have one machine doing it. So if you set your compression level too high for your setup, then you just won't be able to make your plots in time all the time, and you're going to miss out on that. and that goes up. The costs go up exponentially, so that falls off pretty fast at some point.
Right. All right, thanks. This one I want to touch on because it's been really prevalent in the community everywhere. The forums, Reddit, Keybase, it's kind of BS, and I want us to kind of put that to rest. As lots of the community know, and those who don't know, there's been a very persistent campaign of FUD by a particular individual or group of individuals. For those who aren't really heavily involved in the crypto community outside of Chia, FUD's what we refer to as fear, uncertainty, and doubt. It's basically like concern trolling. Anyways, there have been a lot of DMs going out to random people in Keybase and forum posts and things where basically someone is implying that there already are FPGAs that can get 78% compression on our plots in China, and that they are close to releasing ASICs. Do you guys want to kind of talk about why like we really don't believe this is true, and not in a dismissive way, but in a just pure facts, we would know if this was true kind of way?
If it wasn't obvious, 100% compression would just be a plot. This is what plot grinding is. It is 100% compression. You're just trying to make the plot on the fly instead of storing it. So you don't need an ASIC. We already just showed you that it's super fast on a GPU, but you need a lot of memory. So trying to do this in an ASIC, the algorithms we chose for the plotting, like Play 3, isn't sped up by an ASIC tremendously. It's just done perfectly fine on a CPU. So.
It's also
as someone who cut a check for an ASIC recently, Gene, you want to talk about the economics of this?
Yeah. So we spent nearly $7 or $8 million to get Time Lord ASICs. So that's the starting price. And that's not necessarily getting you the very best. The issue is actually more about what ASICs are good at and not good at. The reason we chose K32 originally was that it became very obvious to us in practical use that the limitation was actually the memory bus. It was how fast and how wide the memory was between whatever you were using to compute and whatever you were then storing in memory, and then whatever you were doing to put them off to disk. Now, in the GPU grinding attack, you're not saving them off the disk, right? And so your only bus question is how fast and how wide and how big is the memory between the GPU and memory, right? That remains the problem. And so like building an ASIC with a bunch of memory in it is extremely expensive because the memory cost itself is in every single ASIC. So it actually probably turns out that what you really want to do is you want to build a bigger PCIe or PCI 5 bus and put a bunch of GPUs in that. That beats the hell out of trying to build your own ASIC, and you get the cost savings of general purpose hardware to be able to grind. The point behind the chip is to make sure that grinding becomes not very interesting or gets even less interesting from a cost perspective. And look, to be very clear, you probably can grind space on a GPU if you have a DoD acquired supercomputer cluster of GPUs, but it's a couple $1 million to generate 500 terabytes. So it's much easier to generate 500 terabytes with an older GPU, a NUC. Well, you need a little larger case, but you know what I'm saying, and just store them on storage.
Yeah, the thing that keeps going back to all of our blog posts and all the data we post every time someone brings this up, and I have to remind them in various Discords I hang out in, is that with the right hardware, yeah, you could probably create plots, but you're gonna spend millions and millions of dollars to maybe hit one plot a week. You're lighting money on fire. You're literally lighting money on fire.
Yeah, and again, this is if the folks read the blog post on plot grinding, we describe the economics of it, which I eventually, right, you're gonna if the plotting algorithm can be parallelized with multiple GPUs and other stuff, people will be able to throw lots of money at this and make it go super fast. And the point is, if you do that, this is not, there's no free lunch. It costs electricity, it costs money to buy these cards. And the profitability of that versus just farming, normal storage space is not going to be anywhere reasonable. And the whole point of the chip is to make sure that in the future, with these devices that are getting much faster, and memory is getting faster at a very rapid pace, that we stay on top of it and that it doesn't ever become profitable.
And that first sentence of yours hits the nail on the head. The economics of it. And that's what people need to remember, is that everyone keeps throwing back at us. You can't, no technology is perfect. There will always be better technology. And the answer is, you're 100% right. We're not saying our technology is perfect and will never be triumphed by future better technology. What we're saying is, the economics of the future technology, our goal is to always keep those economics unfeasible so that it is not economical to do what you're doing. And that's why we have things like the filter reduction chip, because those are our levers that we have built into this to pull to always keep it uneconomical.
Yeah, by design, because this is Nakamoto consensus, it is the case that someone with sufficient resources could come in and 51% the entire network. The idea is to make it so that by design, the most efficient way to do that is just using ordinary storage, and that the amount of just storage that's sitting around there out in the world is easy enough to get up and running and widely distributed enough and over provisioned / cheap enough that it's completely impractical for anyone to attack it. And that thesis has largely been borne out by our massive net space, despite, you know, a pretty big drop in coin price. So we continue to feel good about that.
And on that exact topic, I wanted to go into another FUD related question that it looks like Gene beat me to tagging on this. I was going to throw it his way anyways. This question is phrased anonymously in the exact same terminology that I've seen thrown in Keybase and forums as well. So it kind of comes from one of the same sources, I suspect. They're not calling out specifically what they're referring to here, but I think we all know what pool they're referencing. And the amusing part is the pool in question is like, we wish we could have this problem. We will never reach this number. And the question is, they expect that this compression is going to make the final vestiges of the OG only pools that are before we had pooling NFTs and before we had pooling at all as an option, what's left of them to finally no longer be relevant and shut down as people replot. And that in doing so, they estimate, which is an estimation that no one agrees with, not even the pools in question, they estimate a specific pool, and I'm pretty sure they're referring to space pool here, is going to end up with 51% of the net space for their pool, which is totally not feasible. But I'll let you go into this, Gene. Yep. And that would become a security risk. What is our thoughts on this, and how are we going to prevent this from happening?
So first of all, the amount of net space in a pool has absolutely no impact on our security. Okay. If you are not signing your own blocks, it might, and there's only a couple pools that go anywhere close to doing that. But the actual 120,000 validators all actually sign their own blocks. If you want proof of this, XCH Scan has the top farmers of the last basically 24 hours. And you can look and see that the winning farmers by farming key ID are 50 plus every 24 hours. So if anything, what this is likely to do is actually make all the pools more decentralized. So the existing OG pools are likely to bleed out into the rest of the community, but there's no reason to believe that, for example, folks who are currently pooling in, for example, HPool OG aren't going to just go over to HPool Modern. And so, and if anything, that makes that group of pooling even better. Because, by the way, the top farmer right now is HPool OG because it's got such a concentration and signs those blocks. So it's a huge win for decentralization to get people to move to the new, NFT plot style. And this is a major impetus to do that. So if anything, it's going to make us much more secure.
Our pooling community seems to be pretty well behaved, that basically all of them has wanted people to go to the non-OG protocol once it came out. And most of what you have for OG plots is stuff that's just left over from before that was available. And so to the extent that people have incentive to replot, that's great.
All right. So with our official plot format coming out, as I call it, official plot, I guess that's what they phrase in the question. I'm not sure we want to use that exact term, but with our version of compressed formats coming out, do we suspect it's going to kill wild formats? They call it like no SSD. And what I think they refer to as wild formats is no SSD kind of came out of nowhere. It's closed source. It does some weird stuff. They're not very open to the community over what they're doing or how they're doing. There's other ones out there that exist, like the one from Mad Max, that's very communicative with the community, very, shows what they're doing, still a little closed source, but it's very involved in the community and providing kind of reassurances and understanding of how it works. This one's not. Do we expect this will kill that? And do we expect it will make it irrelevant? Before you touch on that, Bram, I do want to preface with, we don't build anything with the intention of killing anything in the community or destroying anything in the community. We like stuff in the community. We do have concerns about closed source stuff with very evasive developers who are not straightforward. And while we won't actively even then take actions to quote unquote kill them, we are not going to make decisions with a mind towards let's not hurt them, because we don't avoid causing friction for them because they're not, probably doing the best things in the interest of the community at times. But with that said, what are your thoughts, Bram, on what this would mean for plotters like that?
Yeah, I think there's the stuff we're putting out now, and possibly with the thing I mentioned, where we'll likely have another 1 or 2% compression at some point in the future. I think that makes us equal or better to basically everything else, or very, very close. It's sort of on the margins, a little hard to benchmark at some point. Our goal is to make it so that the very best plotting and farming technology is available to everyone for free. That's what we want to have happen. And it's kind of frustrating when people in the community come up with great technology and then try to make it proprietary. We're pretty open, actually, if someone has something really good that they're sitting on and they're like, hey, I put real, time and effort into coming up with this great thing, but I don't have a business model for it. We're actually fairly open to like paying for those pieces of technology to open source them. That hasn't really happened to date, but that's sort of more a path we would like to take than people trying to turn things proprietary.
Okay. Harold, going back a little bit to the plotter you're working on, there's a question on the first initial release we're going to put out to everyone. It's going to obviously have plot compression. Is that going to be purely CPU compression, or will the GPU compression be part of that first release? And what is our target? Like we talked a bit before about how currently it's 256 gigs of RAM. We're trying to get that more optimized. We're trying to get it lower. What is our target expectation for RAM when it comes out, both on the VRAM side for the GPU and RAM for the system?
Yeah, so the first question, it's going to be compression for all currently available plotters, meaning disk in RAM and GPU, probably just up to level 7, just so we can get something out there at first. But then short time after, we'll likely get the next compression levels in there. Most of the work of that is already done anyway. But that one is only recommended to be farmed with GPUs, which will probably not come out. The first farmer will probably not come out with GPU support, because we already have the CPU-based harvesting ready mostly. So just in the interest of getting stuff out there to you guys as soon as possible, we'll likely do this GPU harvesting release later. That decision's not up to me though. That's just the same words we find ourselves currently. As for the RAM requirements, it's going to be 256 gigs of system RAM with an option to do the hybrid plotter, which is similar to something we talked about before with the disk-based method, where you just upload basically what it's equivalent to the temp1 directory, and the disk plotter, you upload that to the SSDs, since you don't need that data until the next phase, I'm sorry. So that would be the hybrid method. You would need 128 gigs. So, but if you want to do everything in RAM and get the fastest time, you need 256 gigs. And as for VRAM, take this with a little bit of a grain of salt, since it might change a tiny little bit. It's going to be currently it's 5.6, I believe, gigs or GIB of VRAM required. So any card with 8, I say 8 and not 6 because we might increase it a little bit. So if you're interested in that, you should be part of the beta program, so we can test all of y'all's cards out there and make sure we when we finalize that, get the right value set in there and make the correct trade-offs depending on the cards that people are using out there. But it looks so far that VRAM is going to be fixed, so it doesn't matter if you have 12 or more, to around either 5.6 or like 6.2 or something like that, 6.4. That's all.
All right, thank you. Let's see. There's variations of this question or references that have come up multiple times now. So I'm gonna give this particular person, they have the most creative way of asking this. So I'll go ahead and give them their 15 seconds of fame. JM and Harold, which one of you is the stable diffusion iteration of the other in this call? Which one's the original and which one's the stable diffusion?
You can guess from
generated image.
Twitter handle, I'm Lebanese. Harold is not Lebanese, so he's wearing
I'm
glasses.
Puerto Rican, so I guess our ancestral background is probably similar, since a lot of people from Spain were mixed with North Africans. So, so that's probably what we're looking a little bit alike.
Okay, Harold, here's one for you. Let's see. These two can probably go into one question here. The first part is, will GPU plotting work for K33 and up? We briefly touched on this at the start when we had a smaller audience. I'll kind of let you go into that a bit more. So will it work for K33 up? And will that plotting of those things double the GPU RAM requirements?
So most likely, yes, maybe not exactly double. We haven't explored it completely, like we haven't sat down and actually basically mapped out everything that we think will be required, but most likely it will double at least the system RAM requirements, but probably not the GPU RAM requirements. They should probably stay the same. But system RAM, if you want to do everything in RAM, will double. So for example, K33 will likely go to 512 or still stay in 256 and use the hybrid mode. So it looks so far like it's going to be like that, but we're exploring some options where we can make it sort of hybrid with any amount of system RAM, which would be significantly lower, but you can still take advantage, I guess, of the GPU if you're using just like your regular gaming PC that has like 16 gigs of RAM or something like that.
Okay. And two other GPU questions I'll put into one here for you. The first is, do we plan to support multi-GPU plotting at launch or at all for that matter? And second of all, do we plan to support AMD GPUs?
Yeah, so we've certainly thought about it, right? The whole idea behind some of the initial phase 1 times we were doing is for this POC for looking at block grinding, and multiple graphics cards are certainly would be an effective way. Now, in the blog post, I kind of go into it, but you can't just slap a bunch of GPUs in a desktop. These are GPUs that have to run at full bandwidth. And so again, if you go take an old server and put a bunch of GPUs in there, they're going to run at a lower PCI Express speed. And so to get a system with like lots of Gen 4 GPUs is actually decently hard now. You need like a third pro workstation or one of these newer end servers. But it is for general purpose plotting. It's not something that's like higher on the list than the other stuff we just mentioned, which is like more practical for a majority of people. But it is cool. And I mentioned, we are doing this research and development on block grinding, and eventually we'll have, a way to use multiple GPUs. It's not, I think Harold can go to the technical details, but the bucketized approach we use, we wouldn't even have to use something like an NVLink or something to link them together. You can actually just send each GPU different buckets and then read those back in host memory. So we know how to do it. It's just not super high on the list right now to get out to regular humans. And then wait, Jay, there's a second part of that question, right?
The second part was, do we plan to support AMD GPUs?
Oh yes, yeah. So the initial plan is we're going to use the cross compiler. For the newer cards, I think the 6 series and above support the ROCm HIP compiler for CUDA, and so that's the plan. We haven't started that yet, but yeah, the idea is that we will support NVIDIA and AMD eventually with this first kind of version. Now, I think there's a question, a lot of people were asking about Mac and Intel GPUs, and there's lots of integrated GPU stuff, and we're going to do some pathfinding on that, but we're going to hold off until we get all this stuff we just mentioned out the door. But those are all really awesome, things we wanted to dig into eventually at some point. I know Harold's expressed some interest in delving into some of the other GPU architectures, but yeah, right now, if we can get NVIDIA and AMD support, we would be very happy. So,
okay. Real quick sidebar to folks. Zoom apparently in the last couple of weeks changed the default to a webinar. When you start a webinar, it defaults to chat being unavailable to everyone, which is a new change that I don't think anyone here knew they did. So I only just now saw the question of, hey, can you enable chat? And so I went and dug pretty deep into the settings and found the obscure thing where that was defaulted off. I turned it on. So the chat now works for the Zoom call. I'm sorry, I didn't realize you guys couldn't chat. I just thought no one was. They were all throwing questions in the Q&A. That was odd. Sorry about that, folks. That's a change that was an undocumented change by Zoom, that default. So here's a question for you guys, JM, I guess. Currently, all the demos that we've showed, the plotters for blade bits running in command line only. Do we plan to incorporate these improvements to GPU plotting into the client GUI as well?
Yeah. So we have a GUI for plotting, so that'll all be plugged into the current one we have. I know Harold is looking at actually doing maybe standalone tool that's a little bit more user friendly to help people replot and do some plotting. So that's something else we're also looking at. But yeah, certainly we have a GUI, and when we release software, we will be releasing it into there. Now, as far as if we release the alpha early, will we have support in the client? Yeah, I'm not sure about that, but yeah, eventually when we get it to the beta program, we'll have a beta build in the beta program. People can go to the Chia.net download page and then get it from there. So,
okay. So this question I'm gonna kind of cover a bit. The question is, we said we're not going to release the plotter until the farmer's ready. But there's groups out there who would like to see the plotter before it's supported with the farmer so they can get hardware ready, et cetera. Have we considered, sharing that before the farmer's ready for those reasons? And the answer to that is, speaking from the developer relations point of view, things of the company is, we're not trying to be secretive, and we're not trying to hide things until a certain point for a big fancy reveal. If you are building hardware specific to Chia, or you're building software specific to Chia and farming, we're not like trying to prevent you from seeing this stuff before a certain point. Like, we're happy to make sure you get support that we can provide you in a way that makes sense in advance. If you already have strong connections or relationships or communications pipelines with our developer relations team, reach out to your contacts there. We can work with you to make sure you're aware of what we can make aware to you to help you get a head start on certain things. If you are a community developer who doesn't have those connections, come make them. Come to Keybase, come say hi, reach out to us. Like if you're building stuff in the community that benefits from knowing this stuff early, and we don't have connections with you, we want to help you. We want to know about what you're working on. We want to support what you're working on. So build those connections. We can definitely try to help share stuff with you guys to better understand the changes that we're building and what we're doing. Because again, we're not trying to hide this from folks. We're not trying to keep this a big secret. It's just we want to release it when it's in a good state that's releasable, at which point, it'll be open sourced and the code will be available and anyone can look at it and dive into it. Second of all, when we release it, as JM's kind of alluded to, we're kind of referring to the first release as an alpha, not even a beta. So it's gonna be pretty early stage. So even then, if we release it then, and that's the first time you guys get to see it, it's not like you're going to be super late to the party. Like you're gonna see it the first time everyone else does, and you may have to do some work to support things, but it's not like we're dropping it on you like really late to the party. So we're happy to work with you guys however we can. So yeah. So let's see here. Next question. This is, I got a couple different questions in different various flavors of this. I'll kind of toss this one your way to start with, Gene, and if you want me to add any color commentary, I can. And that is, was Mad Max involved at all in the development of our GPU plotter?
No, there were two parallel paths. We immediately got interested as we started to dissect what was going on with no SSD. And if anything, it was hard keeping everybody on what they were supposed to be doing versus trying to figure this out and build something. So we actually had a really good plotter for quite a bit of time here. We had engaged with Mad Max because we wanted to potentially reward him for the work that was done there. We could not get to terms, as some people have heard. We can't really say too much more about that, but we wanted to make sure that all of the stuff was open sourced. The main reason we didn't open source was because we didn't want to undermine what he was doing as well until we did or didn't get to terms. So that's why you're going to see us open sourcing our version very shortly. You see it running today. We've had it for quite a while, and we're comparing those two things. JM did a bunch of research on both those pieces. So anyway, there are more than one of these, and we love that as an open source ecosystem. There's going to be multiple things out there, but we want to make sure a pretty darn good one is open source and available from the usual suspect, right?
Okay. So we had some questions about other GPUs, other cards. Obviously the RTX series we covered. There's, going back, I think as far back as a 1060, I think we talked about being supported in one way or another to varying results. There have been questions about other types of cards like P5000s, RTX, obviously 4000s, yes, the newer ones are going to support.
If they support CUDA, they'll support the alpha. There are going to be some bugs and some random cards, probably. Harold mentioned, I think 8 gigs is a safe bet. If you want to be extremely safe and you're going out to buy a new card, like a 3060 or 3070 is like stuff that we're testing on and developing on pretty actively. So, if you have a server, obviously these are not good choices for a server because the desktop GPUs are too big. So I know some folks have had some. We had tested an A4000 internally. Will from our team had tested that, and I think he's at 3 minutes at PCIe Gen 3. So like a Xeon V4 system, like decently old server, with a $400 GPU on eBay and 3-minute plot time. So yeah, but yeah, there's a million different models. We're not gonna be able to test them all, but we're certainly compiling the code to make it support the older architectures as well.
Okay. There is a question about so this question was asked we covered it in the blog post. We covered in one of the ancillary blog posts that goes into a deep dive. We covered it in the FAQ in both of those blog posts. It's still being asked. I want to make sure people truly understand this, and they understand. And that is, will we be able to compress our existing plots? The short answer is no, because the research we did looking into it was you can compress an existing plot. It requires more power and more time than making a new plot. So why on earth would you want to? So we're not going to support it because it doesn't make sense. Is there anything extra you want to add to that, Harold or JM?
Just real quick, I explained the main reason why in that discussion that somebody asked in the Chia blockchain Git repo. So if you go there and look for the title, novel idea for compressing existing plots, I gave a fairly lengthy answer for why phase 3 basically requires you to redo phase 3 completely in there. So it's not really worthwhile to make it to exclusivity just for that.
Okay. On the chip, JM and probably also Bram might want to chime in this. I don't know if he does or not. The current chip for the filter reduction basically stops at 2030. So folks kind of want to know what happens then. Like, what's our plans then? Or do we plan to even let it keep reducing all the way to 2030?
Well, you can't. There's a limit to how much you can reduce the filter, because at some point it gets down to 1. So I think the point we have it at is like 16 or 32 or something like that, at which point it just gets pretty ridiculous to reduce it even further. I guess we could be super aggressive and just
the specifics there are just based on the farming analysis we've done at the current filter, which is 512. A hard drive is taking about 0.5 IOPS or input output per second. Current like 18 terabyte drive farming is like 18 kilobytes a second. So a hard drive rated workload is 200 terabytes a year. So that's 6 megabytes per second. So we're about 400x off that today. And a hard drive, current modern hard drives can do about 170 random read IOPS. So once you get to like filter 4 or 8, you'll probably get pretty close to like maxing out a hard drive, which is not what we want. We want the hard drive to be mostly idle. So the idea is that by the time we get to 32, then we'll be moving on to SSDs, and then we'll need to rewrite the plot format anyways, and it won't matter. I don't make estimations about technology farther than 5 years out. At Intel, we made lots of roadmaps, and they were 5-year roadmaps for a long-term roadmap. I'd say most tech companies don't actually even know what they're doing beyond 5 years. So yeah, I think it's kind of silly to hypothesize about that, but we do have a plan, and the reason why the hard fork is implemented the way it is with the filter reducing is that we can effectively not have to do another hard fork. So this will, if we have to ever, if the filter becomes too aggressive and GPUs stall out on performance capability, and block grinding is just not an issue, whatever, maybe we soft fork it back out and stop it at some point. But we have that option now with the way we've written the chip. But no, certainly people should leave feedback on the chip. There's some good ideas about like, maybe we do a filter 1 year and then a K the next 2 years, and then we swap, so it's like a K every 4 years or something. I don't know the right answer, but the one we came up with should be fairly effective with what I know about the GPU technology coming out in the next, say, 5 years. So
we could get more aggressive all the way down to 1, but that would be basically ensuring that we had to do a soft fork in the future to undo some of it. So there's a little bit of trade-off of how aggressive we get about needing to do something in the future.
Yeah, and remember, this is all in the backdrop of farming is likely to be on used SSD over the long haul, and SSD does not care about the plot filter in any way.
So speaking a bit more about filters and hard forks, there's a question here. Basically, why, when looking at all the options we had available and releasing our own compressed plotting tools and this kind of stuff, why did we, since it's going to spark a new realm of plotting and replotting by people who want to take advantage of it anyways, there's going to be a massive amount of replotting. Why didn't we not look at the opportunity of instead increasing the K filter significantly, which of course requires plotting, change the plot filter as well, so do 2 hard forks, and then pull any other levers we have in general to completely just make compressed plotting not viable at all instead of supporting it? What was the thought process there?
I think people are confusing the compressed plots and plot grinding. So when you increase the K size, it certainly it makes it more challenging to do plot grinding, because now you just need more resources and you've doubled the amount of data you have to process. And for most architectures, that actually 2x the amount of time it requires to do this plot grinding. But for compression, and there is a question along the lines of does a K33 plot take twice as much decompression workload compared to a K32 plot? And the answer is, so a K33 has more bits in there. So there's 2 to the 33 bits per entry rather than 2 to the 32. So when you decompress it, there are more possible options you have to go through in the paths for the decompression algorithm. But the plots can be, the higher K value plots can be compressed. So just increasing the K value in the filter doesn't actually change the compression. You can't completely shut this down. Now, if you guys read the blog post, we mentioned that Bram and I did go through what would changing the proofs of space algorithm to include more plotting tables. This would have an impact on full proof of space generation, because you have to grab entries from more tables if we wanted to do more than 7 or something. So we could theoretically reduce the compression limit from today. The practical limit is about 30%, to where you get to just almost infinite CPU. Say we change the proof of space format, maybe we could get down to 10 or 20, but that would also require massive replot and from every
and that would be painful replotting. Like if we were to change the number of tables in the plot format from 7 to 12 or something, that would I think that would make it so the theoretical limit of compression would be less than 20%, but that would correspondingly make legitimate, normal, honest plotting much more painful than it is right now. And a similar thing applies to forcing everyone to do K33. That also makes actual plotting much more painful than it is right now. And we really don't want to do that, particularly for things that don't really get all that much benefit in terms of resistance to plot grinding.
Alrighty. Before I go to this next question, guys, can you go through the Q&A thing and close the questions that you've either directly answered or indirectly answered? Because I got a huge backlog of stuff here that I know we've already covered. Anyways, Gene, here's one for you. All this focus we've done on this project, what does it mean for the timeline for other features and development work that we've had slated for this year? Has it had any impact on any of that?
Not really, and that's why you're hearing we don't have a good date on when farming of these plots is available. That's because it has to get scheduled against all the other stuff we're doing. As Bram said, he's been focused on poker and payment channels, and that's exactly where we need to be. We're out there improving Chia Lisp and making that much more easy to write and use as a developer. That's right now where the key focus is, because farming and the security of the network is critical, but the utilization of the network is what really ends up driving up its security budget and making it a viable long-term replacement for most financial infrastructure.
Okay. So there's a question here about the beta program. I'll just touch super fast. The question basically is, when does it start and how long will it last? So the way our beta program works basically is that when we have stuff that we don't want to quite release in the main releases to the wild to everyone, but we want people to be able to start using it, we consider it in beta. The beta program has a sign up form that people can fill out. We've shared it before, just fill in some information. People have been signing up for the beta since we announced this. I've gotten some pings asking like, hey, I've signed up, what's the status? And the answer is just sit tight. Generally, if you sign up for our beta, we don't actually process those signups and include people into the beta until we're ready to kick off the next wave of beta stuff. So like right now, the next stuff coming to the beta is going to be this. So like right before we do it, we'll process those invites and get people onboarded. So if you've signed up for the beta, just sit tight. You'll when you hear from us, you know that we've begun working on processing those people. So as to when it will start depends on when Harold and JM are ready to release this stuff and the farmers ready. It's going to be a little bit yet. A couple more weeks. As to how long it runs, we don't really know with betas. We don't start a beta. It's not like when you buy a video game and they're like, oh, we're going to run a beta for this game for like the 6 weeks before it comes out, because those are marketing tools and they have a very set window that it goes for, and it's launched with a plan. And the idea is you do it as a marketing tool more than doing any kind of beta stuff, and it's timed and gated because you have to release the game on a certain date. Anyways, this is different. We put stuff in beta, and really how long it's in beta is entirely dependent on the state in which we release it and people's feedback, and when we can fold it back into the main stuff and then release it to everyone. We could put something in beta and it's out there for 2 weeks and we get only good feedback. We get 0 bug reports. We have 0 testing issues. And we're like, all right, the next release, we fold this in on our regular release cycle. Or we could put something in beta and we find all kinds of unexpected things about unique user environments or unique scenarios that we didn't account for that we have to go back and account for. And it could take 2 or 3 release cycles before we can actually fold it back in. We really don't know. So we don't release a beta with a window in mind. We just release it until the feedback is green across the board.
And a couple comments about what's going to happen with the beta program. We were trying to get to a place where basically almost every release has a week or 2 in the beta program's hands. And the beta program is highly instrumented in a way that we would never instrument the actual release. So we get some feedback from some of the useful tools of, what systems are being run on, how's it doing resource wise, those things. It's going to take us a couple releases to get there, but know that if you're in the beta program, you're going to start getting a heads up basically every couple weeks before we expect to release something to get a beta out there and get it used on everybody's machines.
I don't know if we talked about this earlier. I don't think we did, but I saw the question here. If we do the hard fork Bram for the plot filter, if the chip passes and we do it, is there anything else that we want to include in that hard fork specifically with it that you want to talk about? Do we have any plans to include anything else with it?
I already kind of answered that one. Very, very narrowly, very specifically. It might be convenient at that time if we already have the BLS soft fork in, if that's already scheduled and working. We might want to make it so that those opcodes work outside of the guard as well as inside of the guard in the hard fork.
Okay.
That's about it. I don't like using hard forks. It's really not the preferred way of doing things.
Okay. Harold, the current plotter that uses 256 gigs of RAM, someone has asked, they have asked you, what happens if they try to do that with 128 gigs of RAM and a lot of swap space?
Right. So we haven't tried it. I imagine you're better off waiting for the hybrid plotter that I mentioned earlier. That would basically just use your SSD to upload temp1 data. So, but go ahead and try it.
I guess that's what the beta program's for. Try it in the beta and tell us your results. All righty. Let's see here. Sorry, I'm filtering through some of these questions still because there's a couple that I know are duplicates. This one I thought we'd covered, but you just recently tagged it, Harold. So I'm guessing you have more you want to say on it. Will we ever be able to make compressed plots with less than 120 gigs of RAM? Like, do you foresee being able to optimize it below that?
Right. Yeah. I think, yeah, I guess we addressed it. Basically, we're exploring that. So to see if people, I guess people with just regular their gaming PCs with 8 gigs, 16 gigs, 32 gigs to see if we can get it to work with that without huge penalties, so they can actually use their GPU to still upload the actual compute to the GPU.
I would imagine like 32 gigs should be pretty easy. When you get down to like 4 gigs, that's a different story.
Yeah, but to even, you know, the fundamentals of how much data you need to write to generate the plot doesn't massively change. So if, for instance, we had a model that was low DRAM, expect it to be 1 to 1.4 terabytes of host writes. And that now you're back to, you need an SSD that's kind of has decent endurance. Which we are looking into, by the way, resurrecting some of that stuff we did with the Chia plotting SSD. So
yeah, it's going to be like 2 or 3 times the size of the whole plot, I think, to write, because basically the simplest form of it is just as you're doing phase 1, you just take each table and shove it out when you're done with it. And then you have to read the tables back in and rewrite out the new thing when you're doing phase 2. And then you do a final write with phase 3. So you're kind of tripling the amount of actual writes that you do over the course of the whole thing.
Okay. We're getting ready to run up here on time, so I'm just kind of scrolling through some of the questions here. Is there anything specifically you guys want to talk about, either it's been asked or hasn't been asked, that you want to touch on while I give you guys the opportunity? Is there anything you guys specifically want to go into?
That last one, you know, we don't want to make this so somebody has to go out and buy a brand new system. Like, we're trying to make it so people can do it on their desktops. But again, there's some trade-offs that we just mentioned. You know, so we are looking into stuff like GPU Direct, where the GPU can write directly to storage, and you know, we're going to do some pathfinding and some other cool stuff. But I just mentioned there is a pretty inexpensive setup you can do, you know, for like all these old workstations are super cheap on eBay, like just dirt cheap. Like there's $70 for like an old HP workstation or something, you know, just, and you can buy a bunch of DDR, like, you know, used off eBay or whatever. So there's cheap ways to be able to do this. I know it's not the answer everybody's looking for, but when you're talking about, like, I just showed you a single desktop that can make 1,000 plots a day. Okay, if you're pretty serious about Chia, you'll probably look into that.
Yeah, it basically boils down to, if you got an old gaming system that's like last generation, it's a hell of a plotter. So,
Alrighty. I think most of the questions that are still what we have here, we've already touched on. That are still here, but I think we've already done them. I don't think there's anything specific we haven't covered. Oh, there's one here for you, Bram, that you tagged that we didn't get to. Where's your kinetic artwork?
Oh, it's over there. You can't see it from here. It's having a problem. It hasn't been working very well for a while. I think, you know, wood has problems where it gets moisture in it and its size changes and you get extra friction and stuff. So I'm not even sure what the best way of getting maintenance on it is. So yeah, so it's just sitting on the wall right now.
toss it in the oven. What's the thing to your right shoulder? That's the other question people would ask.
That is here, maybe I can demonstrate that. Yo, Kali. Come on. Come on, cat.
Cats on cats.
Wait. Is he able to actually call his cat and it comes?
Yeah, come on, Kali.
Well, it's behaving like a cat, as you can see.
Yeah, well, she's looking at me now. She knows what.
Okay, yeah, this is what I was about to say.
Okay, here.
Your cat listens to you? No.
Yeah.
But yes, I know he's getting into here. It's basically a hamster wheel for cats, and it's
Yes.
adorable to watch cats on them. It's hilarious. Well, while he tries to herd cats, which is also his day job, while he tries to do that, one thing I think I want to touch on really, really fast, because we've talked about this in various ways as part of other answers. And we talked about it at the top when we had far fewer people. Does someone want to, there we go. I love how we did see the tail on screen here. Does someone want to explain to folks in a more layman, a more like not super deep dive way as to just exactly why using GPUs for how they're being used in this scenario does not mean that Chia is magically consuming like 50 times more power than it was before?
Well, it's two things. The amount of power you have to allocate to people to plot goes down by about a factor of 4. So it's much less expensive to generate plots using a GPU. And then the amount of power you might have to extend over the period of farming goes up by at worst about 10%. And it's probably a lot lower than that. So, we're trading off those two things. It may be a small net change to total power
There
use.
it goes. Oh,
That-
we had some progress there.
There we go. But to finish, we're going to go from like using 0.19 terawatt hours per year to using like 0.2. It's not a significant change. It keeps being massively more efficient than proof of work and much more secure than proof of stake.
Right. I think the thing that people forget at the very first part that people forget is that if you're using a GPU to create plots, you're creating plots a lot faster. Even if your GPU consumes more power than your CPU, one, you're not bringing GPU flat out like you are with, say, old F farming to create the plots. First of all, you're only using some of the GPU. Second of all, it's finishing the plot faster. So the total power used to create the plot goes down. And people are like, yes, but you keep making plots. And the answer is not normally. Like, it's like a 1%er of 1% crowd who plots indefinitely and never stops and is always buying hard drives. Those are the most extreme edge case whales, or like data centers filling unprovisioned space. The average person who's farming Chia, the vast number of our network, which is who we want the target to be for this kind of stuff, you plot until your drives are full and then you stop. And you don't buy 400 drives and have 4 racks in your garage. You've got a couple drives that you've maybe filled and that's it. And so there's a finite amount of plotting you're doing. That power has gone down. And yes, the farming goes up, but like you said, maybe 10%. Like, in the end of the day, it's not what people are trying to say that it is.
20% of a already small number is still a small number.
Yes, exactly.
But
also, it does mean that enterprises can actually react to net space changes and price changes. So you're going to be able to see more disk space come online more quickly and more efficiently, which is a huge win, actually.
Exactly.
Sure, yeah. Like during the initial Chia mainnet launch, when we saw exponential growth for 2 months, like if we have there's a price to net space imbalance now that will not remain for more than a week or two.
Yep, exactly. Okay, so any final thoughts anyone want to share that we haven't touched on here before we wrap it up?
Just appreciate Mr. Harold over here. Keep building, my friend. As you can see, I've had quite a bit of fun testing these builds over the last couple months. I'm so excited that we're just so close. I know, and I've been getting a ton of requests like, please, can I have this early? Please, I'm trying. We're trying to get it out as fast as possible. Like I'm just as excited. I have a bunch of storage space in my own personal farm to replot, and I have to wait like everybody else. So we're getting close.
Yeah, and something else that we didn't mention earlier, but I've mentioned in chat a few places to folks. Harold's built some amazing stuff. We don't anticipate dramatic changes to it at this point. It's all about getting the farming done. But there is a non-zero, and a 1% of 1% of 1% is still not zero. There is a non-zero but super trivial chance that in developing the farming solutions for this, we find something we have to change that may change how we make these plots. And while we don't anticipate that, it could happen. And it would be really terrible if we gave you guys early access to this. Y'all began replotting in anticipation and then find out that you have to replot your replots. Like, we don't want to do that to you. And waiting to release this until we know all the concrete stuff is how we avoid pain points like that. Like I said earlier, we're not trying to hide stuff from you guys. We've shown it to you. It works. It's awesome. We're really excited to share it. We want to release it when it's ready. There is no reason that we have to release this to you guys in an unfinished state other than excitement and curiosity. And those are not reasons in which we should create pain for you guys. We don't want to create pain for you guys. We want to release to you good quality code. And that's what we're trying to do here.
Yeah. Also, there's a lot of questions we keep getting that are fundamentally very well answered by charts, graphs, and spreadsheets that JM put into the 3 blog posts that matter. So if you have questions, you should make sure you've read all 3 blog posts.
Yes.
Looked at it through the spreadsheets. It's all very well laid out there. You get a real sense of what the actual impact is.
Please read the blog post if you haven't. JM wrote 2 amazingly deep technical dives that, I'll be honest, when trying to help him edit it, it even made my brain kind of turn to pudding at a few places because it was over my head conceptually in a few places, which is a good thing because it means it went super deep. And that is the quickest way you're going to truly understand what you need to do to optimize your particular setup, is to really understand those posts and dive into them. And then from that, I wrote a post that hopefully is a very high level, easy to understand for everyone, quick hit points one That's the primary post. At least read that. If the technical stuff is too much for you, at least read that one. To be honest, I'd say probably a third of what we covered in the call today was covered in those posts, but we anticipated that. It's okay. But the same stuff is covered there that will hopefully help you better understand, what to expect and what you're getting into. With all that said, thanks everybody for coming to the Q&A today. The recording of this, if you've missed the first part or any part of it in between, the recording for this is going to go up on YouTube here in just a little bit once the video's created by Zoom and I can download it. So it'll be up before the end of the morning. And we look forward to seeing you guys at our next full AMA, which will probably be here in just a few more weeks. So thanks all for coming.
Yeah, thanks guys.
Bye, everybody.
Bye.
See everyone.